Hey everybody, this is Johnny Cash, and this Algebra 2 review is on series and sequences. Let's begin. All right, here's some formulas that you're going to use in this one. Arithmetic, your nth term, that's what a sub n means, is your first term plus the quantity n minus 1 times d. The sum of the first n terms is whatever the n is, and then times the quantity first term, this is your last term, divided by 2. Geometric, your nth term is your first term times your ratio, that's what r is, to the n minus 1 power, and the sum of your nth term, if it's geometric, is your first term times 1 minus r to the nth over 1 minus r, and if it's infinite, and r, the absolute value of r, must be less than 1. If it's not, then there's no sum, but if it is less than 1, and it's infinite, then it's the first term over 1 minus r. Okay, let's go ahead and begin. Find the sum of the series. Okay, on this one, you guys, when it's only going up to 4, I just go ahead and list them out, you guys. Instead of we're trying to figure out any kind of formulas, just list out your first term, your second term, your third term, and your fourth term. And this sum means you put plus signs in between them. So there's I equal 1, I equal 2, I equal 3, I equal 4. And then crank those out, and you get 14 on that one. Okay, write a rule for the nth term of each sequence. Okay, here's one. Looks like this one's going up plus 5, plus 5, plus 5. So this one's an arithmetic sequence. So arithmetic sequence where their first term is this guy right here, and your common difference, which is d, is 5, because it's going plus 5, plus 5, plus 5. Okay, so a rule for the nth term is this formula, your first term, and then plus n minus 1 times d. Okay, so here's my first term, plus n minus 1 times 5. 5 is d, and then distribute the 5 through, and then combine like terms, and there's your answer right there. Okay, this one here, since it's d, that means it's arithmetic, and it says your eighth term. Okay, now remember, it's arithmetic, so I need my first term. So if my eighth term is 54, I'm going to put in 54 right here and put in 8 minus 1 right here. And since d is 7, I'll put it in right there and solve for a sub 1. Okay, 8 minus 1 is 7, so 49. If I take away 49 from both sides, I get a sub 1 equals 5. Okay, here's the formula, and then I'm going to plug in 5, and I'm going to plug in n minus 1 times 7, so distribute the 7 through, and you get 7n minus 2. Okay, this one looks like it's not going plus anything. In fact, it's going divided by 4, divided by 4, divided by 4. This one's a geometric one. Your ratio is to pick any two numbers, and it's always the right number divided by the left number. I like the small numbers. 1 divided by 4. That's my ratio, 1/4. Okay, righty divided by lefty, I call it. So your first term is 256. Common ratio is 1/4. So just plug them in, you guys. It's 256 times 1/4 to the n minus 1. And that's it. You can't do anything else with that mess. That's your answer. Leave it right there. All right, so okay, this one here, this one's geometric. Whoop, I jumped ahead a little bit. This one's geometric because they gave me r, and they gave me my second term. Okay, so I'm going to put in my second term right here is 200, and it's going to be 2 minus 1 right here, and it's going to be 5 to the 2 minus 1 power. 200 equals a sub 1 times 5 to the 2 minus 1. 2 minus 1 is 1, which is 5 now. 5 to the 1 is 5, so divide by 5, you get 40 for your first term. Okay, so my formula is a sub n equals my first term times r to the n minus 1. That's your answer. Can't do anything else, you guys. That's your answer. Okay, find the sum of the series. Okay, so this one is, if you check it out, if you plug in I equal 1, I equal 2, I equal 3. So if I plugged in I equal 1, 2 times 1 is 2. 3 plus 2 gets me 5. If I plugged in I equals 2, 2 times 2 is 4. 3 plus 4 is 7. If I plugged in 3, 2 times 3 is 6. 3 plus 6 is 9. Plus all the way up to, here's 2 times 15 plus 3. Okay, so this one is definitely arithmetic, you guys. So I'm going to go ahead and use that formula. So it's going to be my nth term is 15. This is my first term. This is my last term. I need my first and my last. So 5 plus 33, and now it's just number crunching, you guys, and so we get 285. Okay, this one. Okay, so if I plugged out those guys right there, okay, if I when I equals 1, I get 1 minus 1. When I equals 2, I get 2 minus 1, which is 1. Here's when I equals 3. 3 minus 1 is to the 2 power. Okay, so I'm just showing you that this one's a geometric one, you guys. This is 8, this is 16, this is 32. It's going up by times 2 times 2 times 2. So r equals 2. In fact, this is r right there. That's always r inside the parentheses right there. Okay, so I need my first term, which is this guy, 8. 1 minus r, which is 2 to the nth power. N is 9 over 1 minus r. All right, so there we go. Plug them all in and crank out the numbers, and we get 4088. All right. Okay, this one here. Okay, this one, look, it's going up to infinity right here. So this one might be that infinite geometric series. Okay, this is R right there. That's R. So if you plugged in R and check it out, oops, I went to, so R, since the absolute value of R is less than 1, then it does have a sum, you guys. Your first term over 1 minus R. So let's get our first term, you guys. The first term, when I plug in 1 right here, 1 minus 1 is 0. Okay, so it's 7 times negative 3/4 to the 0. And anything to the 0 equals 1, so my first term is 7. Okay, so 7 is going to go right here, and then negative 3/4 is going to go right here. All right, so it's 7 over 1 minus a negative 3/4, which is 7 over 1 plus 3/4. Now common denominators, 1 is equivalent to 4/4, so it's 7 over 4/4 plus 3/4, which is 7/4. And when you have 7 over a fraction, you invert and multiply that fraction, and then the 7's cancel, and then that comes out to be 4. All right, one more. All right, so this one's another infinite geometric series. There's R right there. R is negative 1.3. And since the absolute value of R is not less than 1, then this one has no sum.